Ever wondered what nuclear physics is all about? Excellent! You've come to the right place. I've gathered three young volunteers, to help teach you what you need to know about nuclear physics. It might even save your life, so listen carefully, my friends. But first, I'll have to introduce my fine young assistants. This is Cindy. Cindy is an American kid who likes candy and normally has 10 teaspoons of sugar in her coffee, which is likely the cause of a high-strung personality.
Hello, everybody! Narrator, where's my candy?
This is Mark. Mark spends most of his time playing, thinking, watching, reading and breathing football. He supports the German national team because he's half German.
Well, of course, Germany rules.
And finally, this is Rikuto. Rikuto is a Japanese pretty boy. He hates everything under the sun, including the sun, especially the suicidal, the nerdy, the avid soccer fans, shopping malls, anything sweet and adorable, and if I have to carry on with this list, you'll never hear the end of it.
Oi! I can't believe I agreed to do this.
Now let's begin with a small description of a typical atom. My lovely assistants will carry on from here.
Atoms are mostly space. The nucleus is very small compared to the size of the atom, and it contains most of the mass and all the positive charge.
Hey! The particles look like gumballs!
They are not gumballs. This diagram was developed by a dude called Neil Bohr, who was awesome because he used to be a footballer.
Guys, shut up!
Ah, pretty boy talked.
Go away!
Fine.
As I was saying, atoms become radioactive when they have unstable nucleus. There are actually three types of radiation: alpha, beta, and gamma.
Let me show you the symbols. This is alpha, this is beta, and this is gamma. Alpha radiation happens in the nucleus of the atom. It consists of 2 protons and 2 neutrons. It is the most ionizing type of radiation.
Beta radiation also happens in the nucleus of an atom, and beta particles are much less massive and less charged than alpha particles.
Gamma radiation is a bit different from alpha and beta. Gamma radiation is not particle radiation, but is a wave. Gamma rays have no mass or charge.
So you may be wondering what we use these types of radiation for.
One form of energy where gamma rays are produced is nuclear power. Using nuclear power is said to produce clean energy with no pollution.
Nuclear power plants convert the energy released from the nucleus of an atom, typically using nuclear fission. This emits electromagnetic waves in the form of gamma rays, among other products of nuclear fission in a reactor.
Nuclear fission? Okay, what is that?
Oh my gosh, you don't know what nuclear fission is? Nuclear fission is a nuclear reaction in which the nucleus of an atom splits into smaller parts, often producing free neutrons and lighter nuclei, which may eventually produce photons in the form of gamma rays.
Wow, Cindy, didn't know you had a brain.
I still don't get it.
Here's a simpler way of putting it. As shown in this diagram, a stray neutron is absorbed into the nucleus of a uranium-235 atom. This makes it unstable, and the atom gains 1 neutron, making it an unstable uranium-236 isotope. Fission causes it to split, producing gamma radiation and other different products. The emitted neutrons go on to split other nuclei, causing a chain reaction.
The chain reactions in a nuclear reactor are controlled, unlike those in a nuclear bomb.
The word to describe the point at which enough mass has been added to the atom for fission to occur is called critical mass. So before critical mass means no explosion, after critical mass means it's already exploded.
I remember now. In order for the chain reaction to be maintained, the uranium-235 atom has to be above a certain critical mass. Otherwise, too many neutrons escape, causing an uncontrolled reaction.
The controlled chain reaction taking place in the fission core releases thermal energy and converts water from the surrounding cooling systems into steam. And the compressor adds pressure to the steam, which then turns the turbine in a generator to create electricity.
This electricity is used to power our appliances at home through the national grid.
Can I leave?
Now, a lot of you may think that using radioactive substances as an energy source is clean and effective, but there's also the downside of using them. One big example is the disaster at Chernobyl in Russia in 1986.
Which is why I don't like dumb people, because they make useless mistakes. Back narrator, can I go home?
How horrible!
What really happened was that the reactor in the plant had a sudden increase in power levels due to pointless human errors and resulted in a steam explosion that completely blasted the top off and exposed the core, dispersing radiation.
A great cloud of radioactive fallout was released into the atmosphere, blowing over most of Europe.
Many plants and animals in the area were killed by the high levels of radiation, and radiation in this exclusion zone took a very long time to abate because of the long half-life of the radioisotopes.
It is one of the most tragic man-made disasters in history. The 4,000 people who died subsequently after the accident died of radiation-related sicknesses.
Which is why I don't like dumb people, because they make useless mistakes. Back narrator, can I go home?
Dude, I'm gonna miss the football match.
I still haven't gotten my candy!
I still haven't concluded on what you lot have said. As I was going to say, it's very important not to take nuclear power for granted. The toxic waste produced by power plants take many years for its radioactivity level to be considered safe, and it's not that simple to get rid of. Most are buried in cement casings underground, while some are even dumped at sea, which is very dangerous in my opinion.
Can I go home now?
Fine, fine. Goodbye, everyone.
But, my candy!
Oops, sorry. I have a plane to catch to Korea. Toodles!
Go Germany!
Urusei Baka, it's Japan.
My candy?